In this lesson, we will discuss infinite limits. That is, we'll discuss the notation limit of f of x equals infinity or negative infinity. Let's look at an example. Consider the graph of the function 1 over x. We already looked at the fact that the limit as x approaches infinity or negative infinity is 0. In other words, the x-axis is the horizontal asymptote of this graph. But this graph actually has another type of asymptote called a vertical asymptote. This occurs when the y-coordinates of the function's values get arbitrarily large. This happens at x equals 0. Look to the right of 0. So consider the limit as x approaches 0 from the right. We see that the blue graph is growing without bound. It gets higher and higher and higher as x gets closer and closer to 0 from the right. The limit as x approaches 0 from the right does not exist. The function is not approaching one single number, but the limit does not exist in a special way. It doesn't exist because the function's values are getting arbitrarily large. So the notation we use is the following. We would say the limit of 1 over x as x approaches 0 from the right equals positive infinity. So we're not saying that infinity is a number. We're not saying that this limit exists. We're saying that this limit does not exist because the values of 1 over x are getting arbitrarily large as x gets closer and closer to 0 from the right. Now consider the limit as x approaches 0 from the left. The values of 1 over x are getting arbitrarily large negative. The graph is shooting straight down slightly to the left of the y-axis. So we use this notation to denote that this limit does not exist, but it does not exist in a special way. The values of 1 over x as x approaches 0 from the left are getting very, very large negative, arbitrarily large negative. So now let's be more precise with the definition of when we write this notation, the limit equals infinity or the limit equals negative infinity. We say that the limit of f of x as x approaches a equals infinity and write this notation. If the values of f of x get arbitrarily large, in other words, get closer and closer to infinity, as the values of x get sufficiently close to a but not equal to a. And again, you could define this similarly for left-hand and right-hand limits. But the idea is the values of the function are growing without bound. They get arbitrarily large. And so we say the limit of f of x equals infinity. Again, I want to emphasize that the limit as x approaches a of f of x does not exist. We just say that it equals infinity because it does not exist in a special way. Similarly, we define the limit of f of x as x approaches a to be negative infinity, and we write this notation, the limit of f of x equals negative infinity as x approaches a, if the values of f of x get arbitrarily large negative as the values of x get sufficiently close to a but not equal to a. So the intuition is that the values of the function get arbitrarily large negative. So on the graph, the y-coordinates are getting lower and lower on the graph, and we say that the limit of f of x equals negative infinity in this case, as x gets really, really close to a number a, but not equal to a. Again, I want to point out the fact that this notation, when we write the limit of f of x as x approaches a equals either plus infinity or negative infinity, this notation does not mean the limit is a specific number. In fact, the limit does not exist as x approaches a. But we write this notation to indicate the fact that it does not exist, but it still behaves in a certain way. either the values of f are getting arbitrarily large, and we write plus infinity, or if they're getting very large negative, we write the limit of f of x equals negative infinity. So when the limit of a function equals infinity or negative infinity, we see that on the graph, the function will either shoot straight up or shoot straight down. And this effect is called a vertical asymptote of the graph. So now let's define a vertical asymptote. We call the vertical line x equals a vertical asymptote of the graph of the function f if we have either of these infinite limits. The limit as x approaches a from the right is infinity or negative infinity, or the limit as x approaches a from the left of f of x equals either positive or negative infinity. Again, the picture that goes along with this definition is the graph is either shooting straight up or straight down as x gets closer and closer to the vertical line x equals a. Let's look at an example of some vertical asymptotes. Recall that the limit as x approaches 0 from the right of 1 over x is infinity. Since we get an infinite limit, we say that the vertical line, which is the y-axis, with the equation x equals 0, we call this vertical line a vertical asymptote of the graph of 1 over x. Consider the following graph. Let's identify the asymptotes, both the horizontal and vertical asymptotes of this graph. The horizontal asymptotes occur when x gets very, very large to the right or to the left. In other words, as x goes to infinity or as x goes to negative infinity. Look at the behavior of the graph to the right. As x gets very, very large, it appears that the function's values are getting closer and closer to height 4. So we'd say that the line y equals 4 is a horizontal asymptote of this graph. Likewise, when x goes to negative infinity, we look way to the left on the graph. It appears that the function's values are settling at height 2. So the line y equals 2 is a horizontal asymptote of the graph. Now let's consider vertical asymptotes. So when is the graph shooting straight up or shooting straight down? We see that at x equals 2, the vertical line x equals 2, the graph is approaching infinity from the right, and as x approaches 2 from the left, the graph approaches negative infinity. So either one of those is enough to call x equals 2 a vertical asymptote of this graph. Then if we consider what happens as x approaches negative 1, we see that the limit as x approaches negative 1 is infinity. Therefore, the vertical line x equals negative 1 is also a vertical asymptote of this graph.